Okay, we are recording.
Let's go ahead and start up this quiz.
I bet you the first two are true.
That depends, but
Yes.
in our case, it should be true.
You know, my English class, when I do the weekly report, the first two answers are true. It's like I worked on everything and I pondered after, and then the third one says I procrastinated to the very end. So you have to hit false on that, and I'm like, true. Oh wait, read, think. Almost trips me up every time, man. I'm like,
You just get in the flow of clicking all the buttons, and then
yep, yeah. And then I'm like, oh no, I don't want to give up an easy point here. You know.
well, I think the first real question is C, but I'm just trying to pull up the. Sorry, I didn't even read it. I don't know, it just rang true with me for a second, but
Right.
let's see. Yeah, that's it.
Okay, let me get back over to it. So the true linear regression equation is where BO and B1 are unknown. What are the null and alternate hypothesis? And you should, which one, the third one, C?
Yeah.
B1 equals 0 and B1 is not equal to 0.
It's in 4.1 of the textbook if you have that up.
I do, 4.1, okay. 4.2, 4.1. Oh, okay, I got you, yeah. The independent x does not affect the value of the dependent y, the null and obvious test. Okay, cool.
Well, 1 for 1.
Yep.
Like 3 for 3 so far, right?
Yeah. So a residual is the difference, depends on, let's see.
So at the bottom, chapter 6, it says a residual is the difference between the observed value of y for a given x and the predicted value of y on the regression line for the same x. Is that an answer?
So there's residual is the difference between BO and B1 is the difference between the observed y and the value predicted by the regression line. Does that sound like the same thing you just read?
So the formula says residual equals y minus y hat. So that, I mean, if y hat is the predicted, then that's the correct answer.
Yep, I agree. Third one.
Do you think, is y hat, is that what it means?
I think right there.
Yeah.
So it says residual y minus y hat equals y. Well, hold on.
Yeah, let's just go with that because
Yes.
that's the only one that talks about it.
Okay. I'm good with that. I think we're right.
Yeah. A plot of residuals supports using linear regression when
So to check our requirements, a residual plot and a QQ plot of residuals. So I think it's got to be the residuals look normally distributed, I think.
I don't really understand the question.
Okay, so let me read that question. A plot of residuals supports using linear regression when
Would it be in that table in 3.5 when it says linear relationship? So would linear regression be that first one, so it would be no pattern in the residuals, which would be the last one. I guess that wouldn't be right because it says you see a pattern in residuals.
Yeah.
So never mind.
So I was
So it wouldn't
looking just
be-
above that in 3.4, plot of residuals.
Yeah.
It says if the points in the QQ plot are close to the line, then we conclude the residuals are normally distributed.
Okay.
So I wonder if it's the residuals look normally distributed.
Let's go with that. I have
Okay.
no idea, but I think that would probably be a good answer. For the next 8 problems, use the data found in math efficiency. Use the confidence variable as the explanatory variable and the score variable as the response variable.
So that means confidence goes in first, right? Is that how you read that?
Yes, just like it did last time where we
We
went
did backwards.
But
Yeah.
I remember on one of our first quizzes we did that and we were really confused why it was wrong.
Yeah.
Could not figure it out. But check and see if Michael responded. Nope. Not yet.
Okay. Okay, got everything in. So, compute the residuals for the data using software. What statement best describes the residuals?
What?
I think it's the center one. Because I don't think it's negative.
Yeah.
And they don't reside. Residuals are between negative 40 and negative 25. I don't see any negatives at all on mine.
But
I mean, everything's positive.
the residuals are in D and E, right? It shows the residuals in column E.
Yeah, in column E, you're right.
I feel like there should be some type of
See, and I don't see the residuals at a negative 40. Sheet here and sort it real quick.
they aren't all negative, right? No. So the last one's definitely out. And then let's see, highlight all this. It says insert tab and then click on scatter. That's weird. I don't really.
What's the weird thing? It doesn't even sort correctly. Like I was gonna sort it and see if it. I don't think it's. I think it's that middle one, because the residuals are between about negative 40. I see the lowest one at like negative 23. So.
Dang it.
No, I see a negative 38. Never mind. Scratch that.
Maybe that's just the edges. The negative 40 is just like a rounded edge, but
Right.
They don't form a linear pattern because I just did it in mine. It's like a jumbled mess. So it's
Because you put it
probably
in that
A.
other spreadsheet.
Well, I just made a plot like it told us to in the book. I just highlighted everything and inserted a scatter plot. On 3.3, it explains
Oh, I see what you're.
first
Yeah.
Excel instructions. But I mean, it's not. It doesn't look like it's. It looks kind of like the image right after the following residual plot. So, but I didn't put it in a QQ plot or anything.
I can throw it in there real quick. Well, it follows the QQ plot almost straight line perfectly.
So does that mean they are normal,
Yes.
or they form a linear pattern?
Well, I don't know.
Because there was negative 38, right?
Mm-hmm. We definitely know it's not the last one, so I think we can go one this time, and if we mess it up, we'll know it's the other one. So
Well,
let's go.
we can at
You know
least
what I
get
mean?
it because I'll turn one in, and if that's wrong, I'll pick the other, and if that's wrong, we know it's the last one.
Exactly. Yeah. So we'll do the negative 40 and 25 this time, and go from there.
Okay. Aha. Based on the QQ plot for these residuals, what can you say about these residuals? They are fairly normal, right skewed, or clearly not normal. Probably fairly normal, right?
They're fairly normal. Yeah. It followed the line almost perfectly. So.
Use software to create a scatter plot for the data. Given the scatter plot, residuals plot, and QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? Dang, this sounds bad.
So this is just the 5 rules, and all
Yeah.
we have to do is we've already pretty much figured them out, if I remember right. Let's switch over. So, if the linear relationship should be hot dog shape, and we did see that. And then the normal error term points in the QQ plot are close to the line, which they were. Constant variance, there was no megaphone shape in the residuals, which we would see that in the one, and it wasn't, so we're okay there. And then 4 and 5, we can't check because we didn't do the tests. So I think we go back to the test, we should say there is a linear relationship between x and y. The variance of the error term is constant. The residuals are normal. And then actually we can check all 5 of them.
Okay.
Because, yeah, I think we can check all 5 and be just fine. Because the first one determines if there's a linear relationship, which there was. The variance of the error is constant, which was the scatter plot. The residuals are normal, which is the QQ plot. And the x values are measured without error. We don't know, but we assume they are unless they tell us not to. And observations are independent. Again, we don't know, but we assume they are.
Okay.
So I think we're good to check all of them, to be honest with you.
Sounds good.
So question 9, what is B1, the estimate of the slope?
I got 12.695. Is that what you got?
12.695. Yeah, I had to find it first. Sorry. 12
No,
points.
you're good.
Now construct a 95% confidence interval for B1. So
It's already
10
in there for me.
10.674, right?
Yeah.
And we've got the upper bound is 14.715.
Yes.
And based on the evidence and using a level of significance of alpha 0.05, what decision would you make regarding the hypothesis test? So the p-value is really, really low, so we'd reject it.
Reject the null because the p-value is less than alpha.
Yep.
For hypothesis test B1 slope, if you reject the null hypothesis, what does it mean?
So it means there's sufficient evidence.
That it's not 0, right? Because it's not equal to 0.
Oh, okay.
Because it's equal to 0 and not equal to 0 are the two for this one. So it should be the last one.
The last one, okay.
Okay. Next one says, use data found in Astarian crocodile for the next 5 problems. Head length was used to predict body length.
For which variable is the dependent? So it's the body length, right?
Yeah.
So the body length is dependent. So body length is going to be the y variable, right?
Yes.
Okay.
So it goes in just how it is, I think.
That's what I was thinking too.
I wonder if this is different data.
I think it must be because the other one wasn't this long.
And if you put 60,
Are you still there, Hayden?
for some reason I just got kicked out.
Oh, okay. I was like, oh crap.
Yeah, it was just like, your call ended. And I was like, what?
That's weird.
Did you happen to try the 67 in there?
For which one? Sorry.
I was just wondering because my data seems different. So I was wondering if your data is different as well. What are you getting for the predicted?
If I put 67 in there, or just
Either
the
one.
6? For the 6, I get a predicted 27.687.
Okay, perfect.
So how do we do the margin of error again?
You know, I'm not sure on this one because I mean we'd have to have the mean.
Mm-hmm.
We'd have to have the mean somehow. And I don't know which one that is. And then we just would subtract that by the confidence interval, the upper and lower.
Right.
I don't know which one is the mean. I wonder if it's just the t. Because we can do the upper and lower bound, right?
Right. Right.
For B1. 7.2818, right?
7.218. Yep. And the upper bound, 8.103.
Yeah. Oh man, I wonder which one it is.
And then, sorry, for 18, did you get the first one?
For 18?
Yeah.
Haven't gotten there yet, but
Oh, sorry.
based on your lower bound and upper bound for the last two problems, can you safely say? Yep.
Yeah, that's what I thought too. Okay.
Whenever it says confident in there, that means we're on the right track.
Determine margin of error for this 95% interval confidence.
Would it just be the slope? I'm going to try that.
So you're going to just put the 7.660?
Yeah, I'm just going to see if they're equal, and if they are, I'm going to go with it. Yeah, they're equal. So it's just the slope minus the upper and lower bound, I guess. We'd obviously have to, try it out to see if that's true or not, but they both equal
Right.
each other, the upper bound and the lower bound, so I assume that could be a possibility. 0.442 is what I got.
0.442. And you
Yeah.
did that by taking the slope and subtracting it from the upper bound and then
Yep,
adding
so
it to the upper bound?
No, so it's just 8.103, the upper bound, minus 7.660. And then in a new function, in a new equation, will be the slope 7.660 minus the 7.218, which gives you the same answer of 0.442.
Oh, okay.
And like I said, that could be wrong. I don't know. So it's going to have to be a trial and error, but.
Right. Well, I'll turn in first.
Fingers crossed for the 100.
Okay, so I got everything checked. All right, I'll submit. All right, we missed one. I think we got a 94.4. Find the one we missed. Oh, we missed question 8, the one I was sure about. Lovely.
Well, this is a hard one to guess on because it's a lot of different potential combinations.
Oh, yeah.
Is that the only one we missed?
Yep, that's it.
Okay.
Okay, so let me go back. So maybe, and here's my thought, since we can't prove the last two, that the x values are measured without error and the observations are independent, maybe it just needs to be the first 3. Because that's what we can prove using the software.
Yeah. You want me to do that?
Try that one, see what it does.
%.
Okay, so that's what it was.
I mean, that's pretty much what you thought initially, right? But you
Yeah.
just assumed that they were going to be correct because we couldn't really determine them. But in
Right.
reality, they wanted to know what we could prove definitely, right?
Right. Exactly right.
Well, we did that.
Yeah.
I like how the grade keeps going up. That's a positive sign for me.
It is. Yeah. It's a good sign. All right, let me just fill this out. I guess you don't need to be here while I do that. Do we want to talk about anything else before we cut out for the day?
I was just wondering about because we have to do another project thing. So I guess we could just look over it, and then on Thursday we can go over it, right?
Chat it a little bit, yeah.
While everyone's there. So I guess we can just do that. Just look over it individually, and then
Okay.
um, and then we can just talk about it later.
That works for me. We can do that. Because this one's we got to decide what we're going to do with the data, right?
Yeah, we have to decide what to do with it. Yep. So it's the one that we have to make the inference and stuff. So I don't think it'll be too complicated, but it is a big portion of our. I mean, it's worth 25 points. So
Right.
we want to make sure we do really well on it if we can.
I agree.
But I haven't even looked at it, so I mean, other than that, I don't have anything that I want to talk about. But probably just a matter of me looking at it. So.
Yeah, me too.
So do you want to just do that then? Let's plan on looking it over until Thursday, and then we could, if we need to, we can create a Google Doc and wait and do the Saturday thing again.
And Thursday's the test review, right?
I think so. I'm not 100% sure. Let me check while you're filling your stuff out. I mean, it would make sense that Thursday would be the test review, but
Right.
you never know with this class. I hope it's the test review.
I know. I think it is, if I remember right. But
Yeah, it looks like it is. Yep, it is. So it's
Okay.
going to be pretty long, I guess, too. So we want to make sure that we have.
Plenty of time.
Usually
Yeah.
it's pretty long. So I guess we can just plan on 4:30, and again, that's all right.
Yeah, I'm good with that. Maybe if you want to send Michael the email and just tell him we're planning 4:30 today, that way, just in case he has a rough night at work or something, you can know that's what we're thinking.
Yeah, I'll definitely do that.
Okay.
Well, I think that's probably about it.
Cool. So I have this all submitted, or I should say submitted in here. All right, 100%. Cool. All right. Yeah, that works for me.
Sweet. Let's just plan on that then. So we'll see you on
Good.
Thursday.
Cool. Have a good one, Hayden.
You too. Bye.
Bye.